Okay, students, I'd already gone over the first two questions and put that in a video on your complex numbers. So this is about the exponential growth and decay. I do already have a link up there that shows you all the transformation, how the transformations work with several examples. I just want to point out a couple things that aren't in that video that you need to know for doing this assignment. So you should know that an exponential decay graph looks like this, okay? And you should know that to be decay, that usually this number is between 0 and 1 right here. So what you'll come across in this assignment, though, is it could be written like this: 2 to the negative x. So what you need to understand is this negative needs to first get changed to a positive. Then we can look at the number inside and see if it's between 0 and 1 to know if it's decay or growth. Okay, so I need this exponent to be positive. So this exponent's already positive, so I can just look right away at the b, and it's 1/2, so it's between 0 and 1, so it's a decay. But this exponent is negative, so how can I get rid of this negative sign? Well, I can bring the negative sign, it would normally be here, I can bring the negative sign inside my parentheses. So really what this becomes is y equals 2 to the negative 1 to the x. And 2 to the negative 1, you should know, means the reciprocal of 2, and the reciprocal of 2 is 1/2. So that's why these two are equal. There's two different ways of writing the same thing. Okay? So you got to always make sure on this assignment that if there's a negative in the exponent, you bring it inside and do the reciprocal of what is inside of here. So let's look at two ways of writing the same equation for the exponential growth. We know one way would be y equals 2 to the x. Well, another equivalent expression or equation to this is y equals 1/2 to the negative x. So we have a negative exponent there. That negative exponent then is brought inside of here, and that becomes y equals 1/2 to the negative 1 to the x. And of course, any power to the negative 1 means reciprocal. So now that becomes 2 to the x. So these two are equal. They're the same equation, just written in different formats. Those of you planning on going to calculus, you will see that happen a lot in calculus, where you might come up with one answer, and you look at the multiple choice questions and it's not there because they're written in a different format. So as you get higher in math, you need to learn that you need to start looking at things. Maybe my answer is not wrong. I just have to look at it a different way. It can be written in a different manner. And so here's an example of that. And you will see this on your assignment, your Edulastic assignment that you're doing today. The other thing is I want to point out is with our normal ones on here, we have an asymptote at y equals 0, which is the x-axis. Okay, so I've written that down there. Okay, because there's no shifts yet. Okay, without any shifts, this is the parent graph. The asymptote is always going to be y equals 0, whether it's exponential growth or decay. The other thing to note is this point right here for both these. Remember, that's when x is 0. So if I had this one, if x is 0, 1/2 to the 0 power is 1. So that would be 0, 1 right there. That would be my y-intercept. It's going to ask you about the y-intercept point. So when they ask you at the y-intercept point, you got to plug in x equals 0 and then see what you get for the y. Okay, this case is also going to be the same because 2 to the 0 is 1. So that's also 0, 1. But let's say, for example, if I had the equation y equaled 4 times 3 to the x. Okay, well now when I plug in 0 here, if you ask what's the y-intercept, the y-intercept, remember that means when x is 0. So it ends up on the y-axis. So I plug in 0 here, 3 to the 0 is 1, but then I get 1 times 4 is 4. So in that case, the y-intercept is 4. So don't assume that it's always 1. Because if if you have a number out front, your A, remember they call that A and this is the B. If I have an A, which technically we always do, because I could always put a 1 out front of these right here. So they all technically always have an A. If you don't see it, it's a 1. And that's why you get 0, comma, really it's A, whatever A happens to be. And that's why we got 0, 1 in the first two. And then in this example here, we have 0, 4, because the A happens to be 4. Okay, so just be aware of that as well. So this assignment, this Eduelastic assignment is really about making sure you understand the concept of exponential growth and decay in the graphs and what they look like in domain and range. The domain on all of these, right, are all real. The range, if it's a parent graph like these, it's only y is greater than 0, isn't it? Okay, there's no 0, so there is no x-intercept. So one of the problems asks, okay, here's the x-intercept of it. No, there is no x-intercept. Okay, because we have an asymptote at y equals 0. All right, I think that should cover most of the things but the main thing you have to be aware of is I need to check to see what the exponent is, and if it's negative, I need to bring that negative inside and do the reciprocal. Then after taking care of that, so I get x or some positive value of x out here, then I can look at the b and determine if it's going to be exponential growth or decay. If b is between 0 and 1, it's decay. If it's greater than 1, it's growth. All right, hopefully that should help you out a lot with this assignment.